I want to welcome Dr. Veronica Arias, who is here today to discuss a bison kill site that was excavated by both professional archaeologists and volunteers in the Texas Panhandle. Dr. Arias has been involved in archaeological projects both in North and South America for almost 25 years. She received her PhD in anthropology from the University of New Mexico in 2013 and is currently the curator of anthropology and natural history at the Panhandle-Plains Historical Museum, which is part of West Texas A&M University in Canyon, Texas. There, she oversees the curation, care, and exhibition of the museum's archaeology, ethnology, paleontology, geology, and biology collections. Her research interests include the development and application of geospatial technologies to archaeological investigations. In addition, she is an adjunct assistant professor of anthropology at the University of New Mexico, a state education coordinator for the Society for American Archaeology, and the immediate past president of the Panhandle Archaeology Society. Welcome, Dr. Arias.
Thank you. Thank you, Drew, for that introduction. I also want to thank the Texas Historical Commission for asking me to, or inviting me to be part of this virtual event. As Drew mentioned, my name is Veronica Arias, and I am currently the curator of anthropology and natural history at the Panhandle-Plains Historical Museum. And I plan to talk about some research that I conducted on a collection that is housed at the museum. The collection actually comes from a bison kill site that was excavated in the Texas Panhandle town of Stinnett, Texas, over about 20 years ago. The research that I'm presenting today was actually done in collaboration with another colleague of mine at the museum. His name is Rolla Schaller, and he also happens to be an archaeological steward for the Texas Historical Commission. We completed this research about 2 years ago or so, and it will be included in a forthcoming volume on the Calf Creek horizon. In terms of the talk itself, I want to break it down into these 4 general sections. I'm going to start by explaining the discovery of the actual site and how they went about excavating it back in 2002. Then I'm going to jump into 2014 to talk about how I became involved in the project. I'll go through the different analyses that we conducted on the materials and what we learned from them. And I'll end with some sort of discussion about our thoughts on the overall significance of the project and how it advances our knowledge of the past during this very interesting but poorly understood time period. So for those of you that are not from the Texas Panhandle, Stinnett is in the north central Texas Panhandle, about 60 miles northeast of Amarillo. It's actually the county seat of Hutchinson County. The site was found within the city limits of Stinnett, actually in their main city park. It was found on July 24th, 2002, during the construction and installation of the new city swimming pool, which was on the northeast corner of the of the park. The crew, you can see the photo there on the left. The crew had already dug the pit. They framed the walls, with wood, metal, rebar, and then we're just grading sort of the bottom of what would end up becoming the deep end of the pool when the backhoe operator scraped across the bone bed. This was at an approximate depth of 10.5 feet. Now, it's important to note that it was widely reported at the time that the bison was found at an approximate depth of 14 feet or possibly 13 feet. However, going back and looking at the original site report and sort of piecing together some of the evidence that was left behind in the project records, I think it was actually closer to 10.5 to 11 feet. In terms of the 13 to 14 feet, my best guess is that actually that was the depth after the bison was removed. So from the very bottom of the excavation. Either way, at the very bottom there, you can see what that swimming pool looks like today if you were to go visit it. So, as you can imagine, the pool construction came to an immediate stop once they encountered these remains, and local authorities were notified. Those local authorities in turn contacted various archaeologists, from the National Park Service in nearby Fritch, as well as the archaeologists at the Panhandle-Plains Historical Museum in Canyon. These archaeologists, converged on the site, and they basically identified the remains in situ as a bison, and quite possibly an extinct bison, maybe even a Bison antiquus, just because the skeletal elements were fairly large. And in fact, at first, because there really weren't that many cultural materials that were found in association to the bison, it was thought that it was just a paleontological site. It's just an extinct bison. And it wasn't an archaeological site at all. However, that soon changed when a complete projectile point was found while screening materials from the last bucket load that had been removed by the backhoe. It was material that was just adjacent to the bone bed. And you can see that projectile point in the top right of that screen there. It was later identified as a Calf Creek point, a complete point. Now, in accordance with the Texas Antiquities law, the Texas Historical Commission in Austin was contacted, and an emergency permit to conduct archaeological excavations was issued 2 days later to the archaeological steward for that county, for Hutchinson County. The permit number is 2921, and the state gave the trinomial number, the archaeological site number of 41 HC 220. So the bison was laying downslope on its right side and oriented towards the northwest. So here you see two photos that are essentially the same photo, the one on the top left and the black and white on the right. They're just taken at a slightly different angle. Now the one on the bottom left is a close-up of the top photo. You can see the mandible and the top of the spine. In terms of what could immediately be seen in situ there, you have the mandible up there in the top, you have the vertebrae, you have ribs, you have the lower hind limbs, all found in place. Now, both in this photo and as I continued to excavate, they looked for the skull, but it was never recovered. In fact, they extended the unit both to the north and to the east. They removed overburden specifically in search of the bison skull, but it was never recovered. To avoid prolonged delays in pool construction, an excavation plan was devised to remove the bison remains in blocks that would then be finally excavated at the museum, where they would have more time to do that. So over an 8-day period, volunteers from at least 30 volunteers, if not more, from the Panhandle-Plains Historical Museum, the Panhandle Archaeological Society, and just the greater Stinnett area came together to try to get this done. They worked to expose as many of the skeletal elements as they could and to remove them sort of in block units, as you can see here, surrounded by the matrix that they were found in. In total, 8 blocks were removed from the ground and they were transported to PPHM for further excavation. Here you see the largest of those blocks. As it was being pedestaled on the top left, then they shrunk wrapped it to make sure that nothing fell out in transport, and finally lifting it on a reinforced platform to the bed of a truck. From there, it went to the museum, where volunteers spent the next 4 months finally excavating the blocks and cataloging the individual skeletal elements. While they worked, it was sort of a museum display in and of itself. The volunteers would be explaining to visitors to the museum what they were doing and why. The sequence that you see on the right shows the right rib cage, right side of the rib cage as it was being exposed. Now, all the sediment that came from this micro excavation was collected and subsequently water screened to make sure that there were no tiny microliths or anything else in these artifacts in the sediment. The materials from the site are currently housed at PPHM, and it is a state-associated held in trust collection. Now, before they were completely excavated, the blocks were completely excavated, 2 or 3 of them were chosen for a display at Stinnett City Hall. So essentially they made casts of partially excavated blocks. And if you visit Stinnett City Hall, you can see them there today. And this is what you would see. You would see the rib cage from both sides. On the lower left, you can see the, the axis in the atlas, the top cervical vertebrae. Now, again, the skull is actually from a cast from a skull found at a different archaeological site. They just put it there for reference purposes. Now, there were some preliminary analyses that were done back in 2002 on these materials, and it proved very helpful. First, a rib fragment was sent to Beta Analytic in October 2002 to obtain a radiocarbon date. The date resulted in the year, the date of 4,950 plus or minus 40 radiocarbon years before the present. So when you calibrate that date, you get 3,729 BC. For those that are more comfortable with before present, that's basically 5,700 years ago. So that really falls smack in the middle of the Middle Archaic Period, which is what you would expect if you find a Calf Creek point. A second type of analysis that was done in 2002 is a descriptive morphological analysis of the projectile point itself. By a lithic expert, taking measurements, trying to see what it was made out of, those kinds of things. He identified it indeed as a Calf Creek type. You can see actually both sides of it, the reverse and obverse side on the lower right there of the screen. It's a medium to large triangular basal notched point. It's a complete point, which is highly unusual for Calf Creek points. This particular point is about 2.2 inches by 1.5 inches wide in its maximum dimensions. Now, these types of points, as I said, are associated with this Calf Creek horizon, which refers to the archaeological materials of a mobile hunter-gatherer group that lived along the eastern margins of the Southern Plains about 5,000 years ago. This type of point, to my knowledge, has never been found in this region. So the type site is actually the Calf Creek Cave in northern Arkansas that was excavated back in 1968. Since then, they have found lots of these different types of points at different sites, again, in Arkansas, eastern Oklahoma, eastern Kansas, and Missouri. And similar points have actually been found in Texas, both in central and south Texas, although in Texas, they don't traditionally call them Calf Creek points. Instead, they call them Bell or the Andes type. The Andes is a little bit bigger and the stem is a little bit bigger. The Bell is a little bit smaller than the Calf Creek. I think most of the people that are, really familiar with the subject currently think that they're all actually variants of the same projectile point now. The Bell and the Andes and the Calf Creek are either variants of the same projectile point, like local adaptations by the same types of people, or perhaps they represent different stages of resharpening. In terms of the raw material, what the Stinnett point was actually made of, the point analysis was inconclusive in 2002. It concluded that it was probably a chert of an unknown origin, indeterminate origin. In addition to the radiocarbon and the morphological analysis, they also did an analysis of the snails that were recovered as part of the site excavation. A few, I think 2 or 3 of the taxa were identified. All of them were land snails, and they are associated with a semi-arid scrublands. And that's sort of where the project ended in 2002. That's the limits of what was done, and But now we jump to 2014. In April of 2014, a symposium on Calf Creek was held at the annual meeting for the Society for American Archaeology, which was held in Austin that year. And as part of that discussion, the Stinnett Bison site came up. So shortly afterwards, I was contacted by Don Lose, who was a chair of that symposium, and he was requesting more information about the site and the collection. Where is this? Where is this material? Has anybody ever looked at it? Those kinds of things. He told me about an effort that was currently underway to create a compendium of Calf Creek occurrences, patterns, adaptations across the Southern Plains. A few months after I spoke to John, Don Wyckoff from the University of Oklahoma, who specializes, on the Calf Creek horizon, came to the museum. Now, looking through the collection together, we realized that there was really a lot of work that still needed to be done. We could really still there was a lot to still be learned by studying these materials. For example, very few of the skeletal elements had actually been identified. They've been cataloged, but they hadn't been identified. So we didn't actually know how much of the bison skeleton had actually been recovered. So from this meeting with Don, the current project was born. Don would take a few of the skeletal elements on loan. He would try to obtain a new radiocarbon date for them, because after all, the radiocarbon has, the technique has refined some in the last 20 years. And he would also try to get a bison expert in Oklahoma to identify the species of the bison definitively. In turn, Wallace Schaller, my colleague at the museum, and I would identify the materials that were found at the site. We would do an in-depth faunal analysis, but in addition to that, we would pursue other types of studies that would better inform on the site, like lithic sourcing studies, paleoenvironmental studies, and I'll talk about each of these individually. I do want to mention something about Rolla, my colleague in this work. He participated in the excavations back in 2002. So this was critical because he really helped to fill in some of the gaps that existed in the project record. So it was easier to reconstruct what was found where, those kinds of things. So in terms of our faunal analysis, we shaded in there what the elements that were actually found or that were actually in the collection that we analyzed at the museum. Our faunal analysis established that much of the right side, upper half of the bison was present. The elements included the complete mandible, all the cervical and the thoracic vertebrae, one lumbar vertebra, ribs, the right limb from the scapula all the way to the carpals, the wrist bones, and both of the metatarsals, so the lower hind legs. Notably, most of the left side of the bison, the skull, the lower back, the pelvis, and the leg bones were absent. There is very little weathering on the material, which in addition to the bones found in articulation, would suggest that the bison was quickly buried after the kill. We looked very hard to try to find some cut marks because that would give evidence of butchering. However, we didn't find any. We did find some gnawing marks on a few of the elements, and that's what you see in the lower left photo there of that rib. You see those little teeth marks there. So that is an indication that there was at least a small degree of scavenging by rodents and other small animals on the site after deposition, after it was deposed. Bone surfaces did also have extensive root damage on them. This suggests that the bison, while buried soon after the kill, may have been shallowly covered for some time, while the grass roots were able to take hold and actually alter the bone surfaces. Interestingly enough, it wasn't all bison, mostly bison, but we also did find other faunal remains, including parts of a jackrabbit, other small rodents, a possible turtle, and a mammal that the fragments were so small that we couldn't get them identified. Now, specific studies to determine the age, the sex, and the species of the bison were conducted by Lee Bement over at the Oklahoma Archaeological Survey. Based on his analysis, he concluded that the individual had been a large bull over the age of 12 years at the time of its death. There was extreme tooth wear on his lower jaw and on his mandible, and also the long bones had been fused. Here, just for comparison purposes, I put the scapula, so the shoulder bone, and the humerus, the upper arm bone of the Stinnett bison right next to the modern bison, just to show that these elements are bigger, they're more robust, so it certainly came from a bigger animal. A second radiocarbon sample from the radius was sent to UC Irvine and resulted in a date of 5,115 plus or minus 20 radiocarbon years before the present. Again, calibrated, that's 3,897 BC. This date was obtained using newer and more accurate pre-treatment methods in the radiocarbon process. But nonetheless, it's comparable to the radiocarbon date that they came up with in 2002, which is a good thing. We want things that sort of supporting evidence. You know, we want the evidence to corroborate. And once again, it falls well within the Middle Archaic time period. So the best way to determine the Bison species, the specific species, is by studying the skull, you know, particularly the horn cores. But again, as I said earlier, there was no skull that was found at the Stinnett site. You know, maybe was just never there, you know, was taken away. So instead, the men took the metatarsal measurements from the Stinnett bison and compared them to the male, female Bison antiquus, Bison occidentalis, and the modern bison from archaeological sites in Oklahoma. He concluded that the Stinnett bison was a male Bison occidentalis. On this slide, you can see the comparison size of the different bison species. All of them are extinct other than the modern bison, which is on the far right. The Bison occidentalis is where the arrow, you know, the arrow is pointing to it. So it's the, you know, it's sort of this intermediary species between the Bison antiquus and the Bison, modern bison. So it's the second to the right. Now, the second to the left is the Bison antiquus, if that helps you understand this graphic more. And the far left is the latifrons, which is way before there were people here, 200,000 years ago or so. Now, going back to the Bison occidentalis from Stinnett, this is an extinct bison form. It spanned the late Pleistocene all the way to the mid-Holocene. So we're talking about 11,000 to 5,000 years ago. Their remains have been identified at several other Calf Creek sites as well. So one of the puzzling, unresolved questions, you know, centered around that projectile point. What was that raw material? What was it made out of? You know, it didn't look like anything local, but then again, it may have been a local material that might have been heat treated and that altered the stone. It might have changed color. You know, that was actually a practice that was common with some of the Calf Creek groups. So in order to get a better idea of what the raw material was and where it might have been coming from, lithic sourcing studies, specifically using XRF or X-ray fluorescence spectrometry, were pursued. Now, XRF is a non-destructive elemental analysis technique that's been widely used in archaeological research since the late 1980s, early 1990s, to give a detailed analysis of the chemical composition of a particular material. So essentially, by comparing the geochemical signature of, say, the projectile point with known samples, then you can find out whether or not it falls within the range of variation for one of those samples. You know, so that's how you're able to source the material. So in terms of the first XRF analysis, we ended up conducting two. It was done at the Galt School of Archaeological Research. At that time, it was located at Texas State University in October of 2014. Geochemically, they compared the Stinnett point to samples that we had provided of Tecovas jasper from outcrops in 6 different counties across the Texas Panhandle, alabates from the Flint quarries, you know, the Alabates National Monument, not actually from the National Monument, but found nearby in Potter County, as well as some Pearson chert that actually came from an unknown source in Missouri that we happen to have at the museum, and it looks similar. The resulting statistical analysis from that XRF analysis is what you can see here in this visual. The long and the short of it is that our point is on the lower left there, and it's well outside of the clusters of the Tecovas, alabates, and Pearson chert that we had it studied against. Now, there's variability within rock formations, so we didn't test every single alabates variation, every, you know, Tecovas, so, you know, we can't definitively know, you know, based on these results, that it was not, you know, these materials, but, you know, that it's pretty convincing that the material is probably non-local. So that was good to know. But sort of it begs the question, if it's not local, then what could it be? You know, and somehow in all of this, it occurred to us that rather than looking for lithic sources to the north and east, why not look west? So with that in mind, I contacted Bruce Huckle over at the University of New Mexico, and we arranged for a second XRF analysis. Actually, excuse me, the first one was portable XRF. So it's slightly different. But anyway, the second analysis was an XRF analysis that was conducted in May 2015 at the Geoarchaeological XRF laboratory in Albuquerque. That's Steve Shackley's lab. And in this case, they compared the Stinnett point with samples of a particular material that's called Socorro Jasper that is known to occur at two prehistoric quarry sites near the town of Socorro in south central New Mexico. The name of those two quarries are Black Canyon and Cedillo Hill. So you can sort of see a box plot of those results on the right, and you can see that the Stinnett point, I don't know if you can see it, it looks like a little gear, but it is most closely associated with some of the samples from the Cedillo Hill quarry, kind of in the margins of it, but it certainly falls within the range of variation of the materials that were sampled from that quarry. That made us ask, what is Socorro Jasper? We discovered first and foremost that it wasn't a jasper. Because of its high silica content, it looks a lot like a chert, but it's actually a high silica rhyolite material that was known, based on archaeological, studies done elsewhere, that was known to have been exploited, in prehistory by different Paleo-Indian, Archaic, and even into the formative time by different groups. Like the projectile point, it had several of these small little inclusions of quartz, feldspar, and possibly mica. On the lower right corner of that slide, you can see how similar it looks to a sample from the other quarry site, from the Black Canyon quarry. On the map on the left, you can see the location of those two outcrops, those two quarry sites, both south and west of Socorro, I think within 8 to 10 miles of Socorro. Now, in addition to these two known prehistoric quarries, I should mention that Socorro Jasper is known to outcrop in multiple localities of volcanic deposits west of the Rio Grande in south central and southwestern parts of New Mexico. Now, unfortunately, most of those localities have never been studied or geochemically sampled. So it is possible that future testing against these localities might pinpoint a more closely associated source for the Stinnett point. Regardless of where exactly the material might have been procured, the Stinnett point falls within the range of variation for Socorro Jasper, which means that it most probably is made of this material. So I've talked a lot about the Calf Creek and the Calf Creek horizon. So, maybe I should spend a little bit of time talking a little bit about what we know about the Calf Creek and how the Stinnett research falls into the Calf Creek phenomenon. Now, again, as I said, Calf Creek sort of was this, the Southern Plains, but on the eastern margins of the Southern Plains phenomenon, all the way from Kansas, Missouri, down to the coast of Texas. Here's a map that I modified from Sergio Ayala. He actually presented it in 2014 at the SAAs. He had the Bell, the Andes, and the Calf Creek shown differently, displayed in different colors, whereas I changed them all to the same color for this presentation. So those yellow and orange points were sort of the known Calf Creek points that had been found. As you can see, it is really sort of clustered in that site. There are some exceptions, sort of an isolated find in Colorado or Utah, but by and large, its prevalence in the West is not well established. So here I'm going to add in red the Stinnett point, as well as in the lower left, that little blue dot is the quarry site for the Socorro Jasper. And then between, I've drawn the 500 kilometers or the 310 miles that separate the two, the site and the, where the material might have come from. And that's quite a distance. It's 300 miles. Now, while exotic lithic raw materials originating from sources of great distances have been found at a handful of other Calf Creek sites, this does not appear to have been the norm. But again, it has been documented at a few other sites. Now, whether the projectile point that was found at Stinnett reflects a wide range mobility strategy, that these people were just exploiting this huge territory, or that there was some kind of long distance trade that was involved. It's currently unknown. But its presence in the Texas Panhandle would suggest that these groups had some level of contact with areas west of the Rio Grande and perhaps as far away as south central New Mexico. Now, in addition to the projectile point, just three pieces of lithic sabotage were found during the excavation of the individual blocks in the museum. And these actually turned out to be far more important than you would think. I mean, it's just three pieces, but, you know, and you can see those three here. You have a proximal end of a tertiary flake, and you have some angular debris and that kind of thing. All of it is made from local raw materials, you know, either Alavates flint or Tecovas jasper. So what does that tell us? Two things. One is that the group was certainly exploiting local lithic raw materials. So they might have gotten the supported jasper from somewhere else, but they were also, you know, well familiar and exploiting the materials that were available to them in this area. And second, the presence of these cultural materials, as little as they may be, indicates that there was in situ butchering and processing that occurred at the site. You know, otherwise, before we encountered these pieces of debitage in the collection, I couldn't be sure that the bison hadn't been non-fatally wounded somewhere else, and had somehow wandered and roamed into Stinnett City Park, what is now Stinnett City Park, and happened to die there. So the butchering, the fact that there was debitage that was probably used for butchering, that was found on the site, as well as the skeletal elements that were missing from the faunal analysis, really, you know, it's fairly compelling that there was butchering and processing that occurred on site. That was the actual site. It wasn't its primary context. You know, and I'll talk a little bit about the butchering in a little bit, but you know, another unresolved issue about the site was its depositional context. The field crew back in 2002 thought that the remains might have been deposited in an ancient playa bed, you know, or a lake basin. And they based this both on the stratigraphy that they thought that they saw in the profile, as well as the fact that the bison remains was in darker sediments than what was immediately below it. So you have this intermittent spring, the Tarbox Creek, very, very close to the site today. You can see that, you know, so the channel is very narrow within the city limits of Stinnett. However, it widens out into this wash when you go further south of town. So then the question becomes, you know, was this channel here 5,000 years ago? You know, perhaps the bison was not killed in a playa lake, but either in this creek or an ancient stream bed that took a similar course to the present day creek. So to better understand and to be able to answer this question, additional studies were undertaken to look at snails again, look at the diatoms and the phytoliths. So this time, a sample of the snails that were recovered at the site were sent off to a specialist in Wisconsin for further analysis. From a sample of 94 snails, 8 taxa were identified. All of them were land snails. These snails are generally found in upland settings with mixed grasses, on rock ledges, with mixed grasses, those types of things, but basically in a shrub type, you know, of environment. So that was, you know, reinforced what we already knew, but it gave us a little bit more precise information. In addition to the snails, we sent out 1 soil sample for diatom analysis and 3 soil samples for phytolith analysis. Diatoms are microscopic single cell algae whose silica cell walls survive in muddy sediments after they die. So they are often found at lake bottoms and other areas, and they can be used to better understand the environmental conditions under which those sediments were deposited. They can tell us a whole lot about the water properties, you know, salinity and the water chemistry, those kinds of things, among other things. Unfortunately, in our case, The diatom specialist was not able to find any diatoms in the sample that we provided, the soil sample we provided, just the preservation wasn't there. Now, we did have a little bit more luck with the phytoliths that we sent to a different specialist. Phytoliths are the minute particles of silica in plant cells that survive after the rest of the plant has decomposed, after it has died and decomposed. They can tell us a lot about climate, past climate. So there were a few phytoliths that were present in the samples. All of them were non-diagnostic, but they include the forms that you see here on this slide. You know, the freshwater spun spicules, the bulliform, sort of the large cell ones, and the rugulose spheroids. So this slide summarizes what came out of those studies, the microbotanical studies. First, the high carbonate soils resulted in no diatom and poor phytolith preservation. Now, the presence of carbonates in and of themselves is suggestive of a dry environment. They wouldn't occur in a place where there's water that's constantly going through. The phytoliths in the snail data indicate a dry wash or possibly an intermittent stream setting. You know, and another interesting finding, but we couldn't really make much sense of it, is that there was a lot of abundant microscopic charcoal fragments that were found in the samples. Now, whether they reflect some kind of prehistoric activity that occurred at the site, or were simply transported there by alluvial or aeolian processes, we don't actually know. But, you know, that did come out of the analysis. So to return to the idea, you know, so if the evidence seems to indicate that it came from an intermittent spring, we return to the idea of the tar box creek. Again, that is within 200 feet of the site. On the left there, you can see the county soil map for Hutchinson County, and you can see Stinnett proper, that's what you can see. And, you know, we sort of drew in, you know, where the modern course of the tar box creek is. It's a north-south. You can see the Stinnett Bison site just to the left of that. And interestingly enough, you can see other gullies that don't quite connect to the tar box creek, but are off to the west, to the northwest. Now on the right, you see the same view, but just a 2008 ortho photo or air image, you know, actually it's a satellite image of Stinnett. You know, we drew in the Stinnett site in yellow, that's the star, you know, the same streams that you see on the soil map. So going back to the paleoenvironmental analyses that I just went through, the location of the site appears to have been a filled arroyo or an ephemeral stream of some kind. Now, it might have been a prior course of the tar box creek or remnants of a different paleo channel together. Now, an interesting idea to me is that if it was the latter, if it was really a paleo channel that existed somewhere in that area, then that paleo channel may have intersected with what remains of that gully to the northwest. In this purely hypothetical scenario, then the bison might very well have been killed near the confluence of two arroyos. Now, again, this needs to be further studied. I'm not quite sure how they'd go about doing it, but they need to find more compelling evidence to support that idea. You know, nonetheless, I think it's an idea worth pursuing. Okay, the results of the research corroborate that the site 41 HC 220 is a Calf Creek site of the Middle Holocene period. It's an isolated bison kill site, and the remains appear to have been rapidly buried, most likely by aeolian processes. The identification of the bison species as a Bison occidentalis concurs with similar findings at other Calf Creek sites. Now, the presence of lithic debitage is suggestive of butchering, as does the absence of several high-quality skeletal elements, including the left scapula or shoulder blade, the forelimb, the pelvis, and both of the hind limbs. So what I'm trying to say there is, based on what we know of butchering at other archaeological sites, usually the high choice, the high meaty parts of the bison or other animals that hunters are interested are precisely some of the elements that are missing from the bison site. So it's very possible that what we found is what they left behind. It's possible also that a secondary processing area may have existed nearby where skeletal parts might have been transported for further for further processing. This could help explain the lack of cultural materials that were found at the site. The lithic procurement strategies at the Stinnett Bison are highly informative. You know, on the one hand, you have Sabotage that confirms the exploitation of local raw materials. And on the other hand, the identification of Sapporo Jasper as a material for the projectile point constitutes an important and unexpected finding. It is suggestive that the Calf Creek phenomenon extended further westward than was previously thought. The Stinnett Bison, sort of to conclude this lecture, is unlike many of the other known Calf Creek sites. You know, for starters, it is the only site in all of the plains in which a Calf Creek projectile point is found with a partially complete articulated bison skeleton. You know, in fact, many of the Calf Creek points that are found, and there are many of them out there, are found in surface collections or in sites that lack good datable context. Sometimes, lots of times, they just appear in private collections. Moreover, unlike most Calf Creek projectile points that are found, this one was complete. Most of them that they find are actually incomplete due to damage or heavy resharpening. Usually the stem or the barb, something, you know, is missing. So the projectile point, the fact that it was found complete, can help better inform on Calf Creek lithic technology, how they went about making these points. You know, this site also is the only excavated Middle Archaic site in the Texas Panhandle to date. So it stands to provide valuable insights into a very poorly understood period in this region's history. And that's something that I didn't really go into very much, but the site falls in this time period that we call the altithermal period, or in other words, the very long drought, from about 8,000 to 5,000 years ago. I mean, by comparison to the Dust Bowl, it was only like, was a decade. You know, so during this time, it was a moment of extreme aridity in much of the West, and it transformed the landscape in huge ways. And in the past, the lack of sites, archaeological sites from the early and middle archaic, you know, the fact that we haven't found many sites in the Texas Panhandle or in this general region from that time period have basically been attributed to that. The land was so inhospitable, people didn't want to actually live here. You know, so instead, the region, you know, this region's history has been sort of constructed from sites found outside of the region, sort of like Blackwater Draw to the west or Lubbock Lake to the south. You know, while these severe and inhospitable environmental conditions from the altithermal were widespread in nature, the materials analyzed at the Stinnett site represent a local adaptation by cultural groups during a brief and potentially more moderate time period, you know, during the Middle Archaic. So, you know, what it tells us is there were people that were living here. You know, maybe the sites are hard to find, maybe they no longer exist, or they're just under 10 feet of dirt. But at least during part of the altithermal, there were indeed people, you know, living, you know, and thriving in this area. I just want to end with acknowledgements. And there are just so many people to thank for this project. You know, first and foremost, I want to start with the people from the city of Stinnett. They were just incredible from start to finish on this project, particularly in the early, you know, with the excavation. So many people from the community were engaged and contributed in some way to the successful excavation and preservation of this site, or of the remains that came from the site. Of course, the PPHM and Panhandle Archaeological Society supplied both volunteers and you know, expertise in the excavation, both the museum and earlier on the field. Of course, Rala Schaller, my colleague and co-author in this work, Don Wyckoff and John Lose. Deborah Summers was the principal investigator of the excavation, and she was assisted by Jeff Indek. Dr. Indek was the curator of archaeology at the Panhandle-Plains Historical Museum at the time. In terms of the current project, there were so many specialists that helped, and I've put all of their names down there. I really need to note that most of them did their analysis for free. They didn't charge us, you know, so You know, I'm so fortunate that they really just wanted to help us answer these questions, these fundamental questions that we had. Now, the radiocarbon and the microbotanical analyses were funded by the Oklahoma Archaeological Society, or Survey, excuse me. So I'm grateful to them as well. You know, and that's kind of the long and the short of it, Drew. I don't know if you had any questions for me or if there was anything that was kind of unclear.
Sure. Hey, thanks for that. Great presentation. I did have one question. I was going to see if you wouldn't mind, you know, with the lack of a scular pelvis, if you could elaborate on how Lee Bement was able to identify the species of bison.
You know, I prepared a couple of extra slides, you know, of questions that you might ask me, and this was one of them because I was hoping precisely that you would ask me about this question. Because, you know, as you said, you know, the skull and the pelvis are fundamental to do this type of identification. So instead, what he did is he cross-plotted the length of the metatarsal that from the Stinnett site, from the Stinnett bison, with the distal end, you know, the far end of the metatarsal. So he cross-plotted both of those lengths here. And then he compared it with other, you know, Bison antiquus, Bison occidentalis, and modern bison that have been found at other archaeological sites in Oklahoma to see how they fell. And I've added this for, you know, so that the graph is actually from him. Now the key is mine, you know, and just basically showing that there is some sort of overlap between the female antiquus, you know, and the male occidentalis. You know, that's why you actually see them there in the middle, plotted on top of each other. But basically that's how he did that, by sort of looking at the metatarsal as a proxy to the skull. I mean, I looked into this, and this is an established method. They've been doing this at a number of other sites as well. But that's, you know, that's really interesting question.
Cool. Well, thank you. If any of our viewers have a question for Dr. Arias, please feel free to leave them in the comment section below. And that concludes our lecture. Thank you.
Thank you, Drew. Bye-bye.